All right, so last week we talked about converting from exponential into log or log to exponential. Okay, if it's in log, which is this case, then the little guy, which is the base, comes over and picks up the one that's by itself. So 10 to the x would equal 10,000. And then remember the rule on tens is however many zeros there are, that's how many, or that's what the exponent would be. So to go from 10 to 10,000, there would be 4 zeros there. And so x would be 4. 2, the x comes over and picks up the negative 2 this time, equals 1 over 25. So I'm trying to figure out what number I could put into the x that would give me 1 over 25. The negative tells me what? What's a negative exponent do? It moves it to the bottom. Good. So this, you could rewrite this as 1 over x squared equals 1 over 25. And then you could cross multiply. X squared would equal 25 and x would equal plus and minus 5. So it's important to remember that plus and minus because both positive 5 and negative 5 would give you the 1 over 25 there. You could also just hopefully start to get that mental math going and say, what can I raise to the negative 2 to make it 1 over 25? The negative obviously moves it to the bottom. And then the raising something, the square root of 25 would be 5. You just have to remember to do plus and minus. Number 3, the 5 comes over and picks up the 0. So 5 to the 0 power equals x. And anything to the 0 power is what? 1. So x is 1. And then the last one, you've got an exponential and a log happening. And so yesterday, or Friday, we said if the base on the exponential is the same as the base on the log, what do? Cancel that whole thing out, and my answer is just 5. So the same thing was true if it said log base 3 of 3 to the 5th. This would also cancel and just leave me with 5. All right, so 7 from the homework said evaluate the log at the given value of x without using a calculator. So this one says log of x where x is 100. So I just said it, but I'll say it again, that if it just says log, it's log base 10. So this is the same thing as saying log base 10 of 100. So what do I raise 10 to get to 100? And it'd be 2. Yeah, log by itself, I guess I probably should have said that on Friday. I didn't realize I didn't say it. Log by itself is log base 10. So the log on your calculator is log base 10. And then number 8 said evaluate, again, same thing without the calculator. So this time it's log of base A of x, God bless you. And we want x to be a to the negative 5th. So log, why did I put k? That should be it. No, that is. Log base A, God bless you, of a to the negative 5th. And then because the base on the log and the base on the exponential are the same, we can cancel it out and just keep the exponent, which is negative 5. Yeah. So again, we'll start by taking our equation, like if this had said y equals log base 2 of x. We would convert it into exponential, so the 2 is going to come over and pick up the y, drops off, leaving the x by itself. And then we plug in our values, that negative 1, 0, and 1. We plug it in for y instead of x. And then we graph. So just like you did with your graphing homework in 5.1, you're going to need to graph these by hand and then select your graph. It's, again, multiple choice, but your test won't be, or your quiz won't be. So I'm looking for the actual hand-drawn graphs in this homework, and then you can select it from your choice, okay? But make sure you do those. And again, it's going to ask you for domain, x-intercept, and the vertical asymptote. All right, so this looks like this. Graph the log function y equals log base 2 of x. So we're going to start the same way, convert it, so the 2 comes over and picks up the y, drops off, leaving the x by itself. And then I want to use my t-chart. So I want to plug in all right, so again, we're plugging in for the y, negative 1, 0, and 1. So it's still 2 to the negative 1, 2 to the 0, and 2 to the first. 1/2, 1, and 2. 1/2, 1, and 2. And then I get 1/2, negative 1, 1, 0, and 2, 1. So these are shaped this way, okay? They run as close to that y-axis as possible without touching it. And obviously this will change with a horizontal shift. Like if there was a +1, it would shift everything to the left one, and we'd get those points. But that's how the actual shift is going to happen, left and right, which is your horizontal. That means that there's a vertical asymptote at 0 right now. And again, that changes with a horizontal shift. So my x equals 0 is my vertical asymptote. My domain, so vertical asymptote, because that's one of the things it's going to ask for, x equals 0. My domain starts at 0 and goes to positive infinity with a parentheses on both because it can't touch 0. And my x-intercept comes from my graph or from the middle point of my t-chart. I got it by plugging 0 in for y, which is 1, 0. If you want to plug more points in, obviously you can. You would have to plug them into the right of 2, like you can't plug anything less, or to the right of 1. You can't plug anything less than negative. So 2 places. One, you can look at your graph, right? The other is it's the middle of your t-chart, because it's where I'm plugging 0 in for y. Okay. Yep. If you didn't have a t-chart and it just asked for the intercept, you would just plug 0 in for y. All right. Let's do another one. So what did we say the base is on this? 10. So this is saying 10 to the y equals x. Again, plugging in for y, -1, 0, and 1. So what's 10 to the -1? 1/10. What's 10 to the 0? 1. And 10 to the first? 10. Good. So 1/10 and -1, 1, 0, and 10, 1. So my graph looks like this. Say that again. The 10, so it's log without a base is log base 10. Yeah. Okay, so what's my domain here? Is there a shift left or right from my parent function? No, which means my domain is 0 to positive infinity. It means my vertical asymptote is at x equals 0, and my y-intercept, my x-intercept. Again, from the middle of my coordinate point, or from my t-chart, or from my graph, and that's 1, 0. Yep. Questions on that one? All right, so knowing what we know about our parent function, think about what's happening this time. What happens when you add or subtract inside the parentheses? I'll go back. Is it you need me? It's going to shift this left or right, right? So because it's a -1 inside the parentheses, it actually shifts it where? To the right. So now it's going to cause a shift in our domain. It's going to cause a shift in our vertical asymptote. It's going to cause a shift in our x-intercept, okay? You're welcome. Okay, so again, we just said we know this is going to be shifted. So when we looked at our graph, everything should be shifted. We are going to find it with those points, but just so that you can get an idea of what it should look like and what's going to happen with our vertical asymptote is everything's going to shift. So again, the base is 10 because there's nothing there. So this becomes 10 to the y equals, and this drops off and leaves me with x minus 1. So if I want to solve for x, I'm going to add the 1, and I'd get x equals 10 to the y plus 1. So when I set up my t-chart, plugging in for y still, I would get 10 to the -1 plus 1, 10 to the 0 plus 1, and 10 to the first plus 1. So 10 to the -1 becomes 1/10, plus 1 is 1 1/10. 10 to the 0 plus 1 is 1 plus 1, which is 2. And 10 to the first plus 1 becomes 10 plus 1, which is 11. with me so far? Yeah? Okay, so now I got to plot them. So 1 and 1/10 and -1 is about there. 2, 0, and 11, 1. So like all the way over here. And my horizontal asymptote that was at 0, my vertical asymptote, sorry, that was at 0 just got shifted to the right 1 based on those parentheses there. Then my graph is going to look like this. So the easiest way to find your vertical asymptote is just set your parentheses equal to 0. And I get x equals 1. That's where my vertical asymptote comes from. I think that's easier than looking at your graph, but if you can also look at your graph. But whatever's inside the parentheses, you just set equal to 0. So if you think about it, before it was log base 2 of x, I would have just set x equals 0, and there's my vertical asymptote. This is the first time we've had something other than just x there. So our vertical asymptote is at x equals 1. Our domain now got shifted to the right, 1. So it starts at 1, it goes to positive infinity. And our x-intercept, again, from the middle of our coordinate grid, our t-chart, or from our graph, would be 2, 0. Questions on that one?
Why is your domain 1?
So it got shifted. As soon as you get that horizontal shift, which is in that parentheses, it shifts your domain because your vertical asymptote just shifted everything over. So your vertical asymptote and your domain are going to come from those parentheses. All right, now we're adding something separate from the function. What does that normally do to a graph? It's going to shift it up 2 this time, right? This is not a horizontal shift, so our vertical asymptote is still at 0. Our domain is still at 0. So I'm going to rewrite it. This would be log base 10. This time, I have to move the 2 before I can convert it to exponential. So I have to subtract the 2, and I'd get y minus 2 equals log base 10 of x. Now the 10 picks up that whole thing. So it would be 10 to the y minus 2 equals x. So if you have anything other than the log on that side, you have to get rid of the other stuff first. If it was like this, where we're adding something, we're going to subtract it. If there was a negative on the front of the log, I would have multiplied everything by a -1. If there was a number multiplied on the front of the log, I would divide both sides by it. So you have to move everything away from the log before you can convert it. Now I do my t-chart, again plugging in for y. I'd get 10 to the -1 minus 2, 10 to the 0 minus 2, and 10 to the first minus 2. This gives me 10 to the -3, or 1 over 1, 2, 3 zeros, 1 over 1,000. 10 to the -2, 1 over 100, and 10 to the -1, 1/10. So I know my vertical asymptote is still at 0 because there's no horizontal shift. If I had set this equal to 0, I would have gotten x equals 0, and that's my vertical asymptote. These points would be 1 over 1,000, 1 over 100, and 1 over 10 are going to be so teeny tiny in here. So 1 over 1,000 -1, 1 over 100 0, and 1/10 1. And that's really hard to determine a graph from that, which is why you might want to plug in an additional point. So if I just try by plugging in 2 here, I get 10 to the 2 minus 2, 10 to the 0, which is 1. That gives me one more coordinate. So 2, 1. No, 1, 2, sorry. I can even go one further and plug in 3, and I'd get 10 to the 3 minus 2, 10 to the first, which is 10. So 10, 3 is my next point. And then I see this start to turn. So I know because there's no horizontal shift that my domain is 0 to positive infinity, and my x-intercept still comes from my coordinate points on my t-chart or from the graph. That's a little bit harder to see this time, so I would say go to your t-chart, which is the x-intercept of 1 over 100, 0. So sometimes it's not enough based on just those 3 points, and you want to keep plugging them in just so that you know what that curve is doing. Questions on that one? All right, the last thing we're going to talk about in this section is called the natural log. So remember that E is the natural base. Log base E is called the natural log. So this is used in place of log base E, and it's ln. ln is log base E is ln. They are used interchangeably. This is still a log function, so it still has all the characteristics of a regular log. So when I graph this, it would be the same. It would have that same curve. It would have a vertical asymptote. It would have domain. It would have an x-intercept, all the same. The only difference is that my base would be E. So if you would compare this to something, it'd be like almost like the log base 3 graph, because we say E is, remember, E is like 2.7. So if I had log base 2.7x, that's going to be really close to an ln graph, okay? Or if I had log base 3x, it would be really close to a lnx graph. So a couple of quick mental math things. ln of 1 is 0 because ln of, like you're saying, e to what power, right? E to what power would give me 1, and it would be 0. ln of e is 1 because that would be the same thing as log base e of e. So if I had log base e of e, this exponent would be 1, right? And I could cancel this out and I could keep the exponent on it. So ln of e gets replaced with 1 or whatever its exponent is, which is what the next thing is. Ln of e to the x is x, whatever's in the exponent, because it would cancel through and leave you whatever's in the exponent. And then you can use your one-to-one function like we do, one-to-one property like we do on our exponents and our logs on ln. So if I had ln of x equals ln of y, that's like having the same log on either side of the equal sign. We would ignore the ln's and just set what's next to it equal to each other. All right, so let's work through a couple of these. 29 says ln of 1 over e equals x. So you could, like I said, go long way around and do this is the same thing as log base e of 1 over e equals x. I could convert that into exponential. E comes over and picks up the x, drops off, leaving the 1 over e. And then what?
You can reduce the 1 over e to the negative 1.
Okay, e to the x would equal e to the negative 1. Now our bases are the same, and x equals negative 1. That's totally fine to do. It takes a couple of steps. It's completely right, okay? The more comfortable you get with logs, hopefully you realize this is saying log base e of 1 over e. And you should say, how would I get from e to 1 over e? That means I have to move it to the denominator, and that's negative 1. So you can, and the more comfortable you're going to get with logs, the faster you're going to be able to do that. Okay, you can do it with mental math, or you can rewrite it and set your bases, get your bases to be the same. Either way is right. All right, 30, e to the ln of 5 equals x. What do I do here? It cancels out. It's what? Just 5, because this would be e to the log base e of 5. The base on the exponential function is the same as the base on the log. They would cancel out, and x is 5. Long way around is I can take this and convert it to log. So it would be log base e of x equals ln of 5. log base e of x would equal log base e of 5. One-to-one property on either side of the equal sign means x equals 5. So there's a lot of different ways to look at logs, okay? You just have to figure out whatever makes the most sense for you and stick to it. All right, this one says 2 ln of e. What can I do? What is ln of e? 1. Remember, it's just what the exponent is. So this would be 2 times 1, which is just 2. So again, you could rewrite that 2 log base e of e to the first. Log base e of e to the first is just 1, and 2 times 1 is 2. But the faster you learn that ln of e cancels out, leaving you with the exponent, the easier it's going to get. $32. What's x? 1/3. Log ln of e cancels out, leaving you with just the exponent. $33. What's ln of 1? 0. So 5 times 0 would be 0. Remember, in order for that big number to be 1, it has to be raised to the 0 power. 34. Good. This would be 3/4 times 1, or just 3/4. And 35. Just 7. This cancels. That would be log base e of 7, and x equals 7. Questions? All right, we're gonna 17 on the homework looks like this. ln of x plus 8 equals ln of 13. So we just use the one-to-one property here. Ignore the ln's, right? And say x plus 8 would equal 13. X would equal, subtract the 8. And x is 5. So that is like for number 17 and 18, it's like that. But other than that, you're good. You could do the rest of them. You could do all of the log graphs. Just make sure you're graphing, again, by hand, and then selecting your choice. If you leave this all for Wednesday, you're going to hate life Wednesday night. So don't do that, okay? Get it started, especially those of you that are not freshmen. That means you have an extra day tomorrow. You can do it before it's due. All right. Any questions on what we covered today? Okay.